Hi, and welcome to the Worldwide Center of Math's Problem of the Week. This week we have a combinatorics problem that we're going to do, and the problem is you are given a 10 by 2 grid of unit squares. Two different squares are adjacent if they share a side. How many ways can you then mark exactly 9 of the squares so that no two marked squares are adjacent? So to begin, we've just drawn out the 10 by 2 unit square grid. And really, if you think about it, since we're only marking 9 squares and each square, we're trying to make each marked square not adjacent to another marked square, you know that there can only be one square per row. So what that basically tells us is that 9 out of the 10 rows will have a square. So that gives us kind of two cases of what can happen in terms of the combinations of where to put the marked squares. So case 1 is that either the first or last row is empty, and we've put that into one case together because if you kind of look at the grid, if the first row is empty or the last row is empty, those are kind of basically the same situation. So what we're going to do is find the combinations for, just focus on one, so focus on maybe the first row being empty, and then double the amount of combinations that we find, as it's the same for the last row being empty. In case 2 is that the empty row is not the first or last row. It's one of the rows in the middle, randomly placed somewhere else. So we're just going to focus right now on case 1, and we're going to focus on the case that the first row is the empty row. So if the first row is the empty row, we then have to fill in all of the 9 consecutive rows following that. And for row 2, for where we place the marked square, there's really two options. We either place the marked square here, or we place the marked square here. So there's two options, and based on where we place the marked square in row 2, we then know that the next square in row 3 can't be in the same column as wherever we place the first square in row 2, because then those squares would be adjacent. So depending on where we put the marked square, either in this column or the second column, it then kind of dictates where the square in row 3 must go, the square in row 4, and so on and so on. So really, where we place the first square dictates the entire rest of the tiling of this grid. So in total, there's actually then only 2 combinations in the situation that the first row is empty. And because the first row and the last row being empty are symmetrical in terms of the 10 by 2 grid, we also know that if the last row is empty, there are an additional 2 configurations that we can tile the plane in that case. So in total right now what we have is just 4 configurations for the way that we can tile a plane. So now we can move on to case 2, the case that the empty row is not the first or the last row. So basically what that tells us is that the first and last row must have a marked square in them. So the choices for where we can put the actually empty row is here, which basically gives us 8 choices. The first and last row must be marked, so that's 2. 10 minus 2 is 8. So we have 8 possible combinations for where we can put that empty row. And depending on where we put the empty row in terms of those 8 different spots, what that means is that it creates 2 blocks of kind of tiled squares. So if we put the empty row here, you can see it creates 2 blocks of tiled squares. And that's true for anywhere that we place the empty row in those 8 possible positions. So kind of going back to what we did for case 1, what we know for each block is that based on where we place that first tiled square, that dictates where the rest of the squares of that configuration go. So just focusing on one block at a time, if we focus on block 1, we have 2 choices for where we can put the tiled square, either in column 1 or in column 2. And from there, that dictates where the rest of the tiled squares go. So really for block 1, we then have 2 possible combinations or configurations of what we can do in terms of tiling the plane. Moving on to block 2, we can use that same logic. Based on where we put the first square, it dictates where the rest of the marked squares follow. And once again, there's 2 options for where we can place the first square. We can either place it in the first column, or we can place it in the second column. So once again, that gives us another 2 configurations for how to tile block 2. So in total, the amount of combinations in the case 2 that the empty row is not in the first row or the last row is 8 times 2 times 2, which ends up coming out to 32 configurations. And then we can add that to the original 4 combinations that we found in case 1, 2 configurations where the first row is empty and 2 configurations where the last row is empty. So the total amount of configurations is 32 from case 1 plus the 4 from 32 from case 2 plus the 4 from case 1, and that gives us 36 possible configurations of marked squares. So that's all we have for you today for the problem of the week. I hope you enjoyed watching this video. Please check out some more of our playlists on YouTube, check us out on Facebook, and subscribe on Twitter. Thank you.